second part of this lecture on Chapter 1, we're going to talk about why it is that people's public opinions about the role of science and technology has been changing, and talk about what we can do to potentially use psychology to help educate people and where that information comes from, and we can bring public interest and scientific research more closely aligned together. First of all, the National Science Foundation, as I was talking about previously, has been doing long-term studies about the people's interest and concern and education around science and technology. As I mentioned to some of you last week, that in fact actually two of the areas that psychology majors gain the most out of, and in fact any liberal arts major gains the most out of when it comes to employability, is by taking more classes in science, more classes in mathematics and statistics and data, and then thirdly, actually kind of related, is more experience with social media. So if you can take Bio 30 instead of Bio 10, that probably helps you because that's a higher level class. If you can take Bio 1A and 1B instead of Bio 30, that also gives you an additional advantage. Or maybe you didn't have some of the prereqs to take the LPC Bio 1A, 1B. That's okay. Maybe once you transfer, there's an upper division general interest class in something about science or social media and the role of technology in our lives. All of those will be helpful and would help you to gain a better ability to look for jobs and probably to be able to converse with the people around you. I'll give you a great example. My fiance was a pre-med major at ASU, and but in the end decided he didn't want to do that. But he had gone all the way through the chemistry, the organic chemistry, the bio, the calculus. And in the end, actually, he decided to switch and become a business major and a finance major. So fast forward about 13 years later, he's offered a job working with a tech company, which is where he's worked for a really long time. It's a startup looking at sort of using new technology to analyze organic compounds. So he's familiar with how that process of analyzing organic compounds using technology works because of his organic chemistry class. So in fact, even though he's on the finance team, he's able to actually, during the interview, talk about and understand what their technology is doing. Any CEO or employer where you can converse about their product even though you're not on their research and science team, that automatically is going to give you an advantage over other candidates who can't do that. If you know how to use data and you can understand science, there is some advantage to you. That's not to say that science technology is the only way to get ahead, but our culture is definitely moving towards valuation of science and technology, and unfortunately not valuing arts and humanities as much. Please understand that I believe both of them are vitally important, and just talking about one study on the role of what classes you should take and how it can help your employability later. Okay, so public interest is generally going down, actually, in science and technology, unfortunately. You can especially see this when it comes to the top one on new medical discoveries and environmental pollution. People don't want to talk about it. It's a little bit more variable when it comes to space exploration. Probably the peaks you can see at the very bottom in space exploration probably correspond to more news stories, more outreach from NASA, for example. That probably corresponds to more public interest in some of those things. But you can see that there really is a really variable sort of role in those last three. But clearly, new medical discoveries and environmental pollution, people are becoming less interested in, especially environmental pollution. Let's take a look at that one. So, in fact, actually, public interest in science technology is the highest, and most recently, when it comes to new medical discoveries in comparison to every other issue. When you ask them, are they interested in the role of science technology in local school issues, or new inventions and technologies, or environmental pollution, economic and business conditions, scientific discoveries, military and defense policy, they are moderately interested in them in comparison to, for example, their valuation of new medical discoveries. But in fact, they're the least interested in agriculture, space exploration, international and foreign policy. Okay. In fact, actually, one of the things, the way you can interpret this, well, you might interpret this, is that in fact what's happening is that people are the most interested in medical discoveries because those likely have a direct impact on their lives. They're probably also slightly more interested in local school issues, especially if they have children, or they're planning to have children. But they're the least interested in things that they don't think impact their lives, like agriculture and farm, space exploration, international and foreign policy. And I guarantee you, in fact, that those last three things including space exploration, actually have major impacts. But people may not see it, right? They don't see the role of technology in space exploration and how we then might bring that down and use it to impact other things around the population. In addition, not only is their interest in science and technology going down, but in fact their concern about the environment is also going down. In general, if you were to average these across multiple years, what you've seen is that in 1983 we were the most interested in the quality of the environment, the pollution of rivers and lakes, pollution of drinking water more recently, air pollution, global warming, loss of tropical rainforests. But in fact, over time, but those are pretty spread out in 1989 and 1990, right? But over time, they've actually started converging. So they're getting closer, but they're also generally going down. People are not as interested, right? So how come they're not concerned about the environment? How come they're not concerned about the extinction of plant and animal species as they were in previous years? Why is it that they're not as concerned about pollution of drinking water now as they were in 1999, right? In addition, though, right, so not only is their interest and concern going down, but their danger, their perceived danger about environmental change is actually going up. Now, not up by a lot, but we've probably increased in some of these by as much as almost 15%. So they're almost 15% more concerned about the danger, even at the same time that they say they're not interested and they're not concerned about it. Okay, how can we make sense of that? This is where psychology has power. We call this cognitive dissonance. For those of you that have taken Psychology 3, social psychology, you may have talked about this. Cognitive dissonance refers to a situation in which you have conflicting attitudes, beliefs, and or behaviors. So I believe, in fact, I believe that the environment, I'm worried about the environment. In fact, maybe I have nightmares about it. I can see all the news stories going on around it. In fact, when I hear that, the dissonance causes me to want to restore that balance, right? The problem is that people, when they get this feeling of mental discomfort, this guilt, this ickiness, it leads them to try to alter either their attitudes, their behavior, or their beliefs in order to reduce that discomfort and to restore balance, okay? When somebody tells you that you're a really amazing student, and in fact you think you're not a very good student, you get that icky, uncomfortable, like, oh, why would you say that? No, I don't like that. I'm not that good, right? The way you try to restore that balance is by telling them, no, thank you, but no, you're wrong. I'm actually not that good of a student. When you tell people, when they believe that in fact the danger of environment is going up because of more frequent reporting, that dissonance, that icky feeling, makes them actually decrease their interest and concern. For example, they start nitpicking the science or they nitpick the quality of the reporting. Oh, well, this is done on ABC or NBC or this is something I saw on social media, so I'm just not going to trust that, right? I don't ever want you to be so simple-minded, so simplistic in your interpretation that you don't actually say, right, that you just believe it, right? You basically say, oh, well, it's on social media. Oh, it's my friend who I don't really believe them. What I actually want you to do is look at the science, right? Go down to the level of saying, okay, why do I have this feeling? Why am I automatically disregarding this person's opinion or feelings or data or information? And then try to see what you can do. One of the ways you can reduce cognitive dissonance is by encouraging behavior change, right? So if you're worried about the danger of the environment, but you're not changing your behavior at home, you're not doing anything to help reduce or mitigate that damage, we need to make sure that we're trying to encourage effective behaviors. And unfortunately, one research study shows that in fact we're not encouraging very effective behaviors. Your textbooks in middle school and high school, when they often talk about the dangers of environmental change or climate change, they focus on things that are not very powerful. Change your light bulbs. My parents used to always say, turn off the lights when you leave a room. My fiance even says, turn off the lights when you leave a room. In fact, actually, this study showed, and here's a graphic of it, showed in fact that these are some of those low impact things. If you recycle at home, if you wash your clothes in cold water, if you hang dry your clothes, those are moderately impactful. In fact, if you only upgrade your light bulbs to the low energy light bulbs, that's actually low impact. That doesn't actually help a lot when it comes to the amount of CO2 emissions in the atmosphere. But in fact, the other thing is that news stories often focus on the extreme end. Don't have a child, right? You can see on the very far end of this graph, because if you don't have a child, that's going to make the most significant impact, assuming that the levels of CO2 emission we have today never ever change, and that all of your children's descendants continue to have the average same number of descendants, okay? I don't want you to go to the extremes. Don't focus on your light bulbs. Don't focus on never having children if you actually really want children or you think you might want children, right? There are a lot of things in the middle, right? Move to a plant-based diet. Buy green energy sources. Maybe you try to avoid transatlantic flights, or maybe you try to live car-free if you can do that. There are lots of things in the middle here, right? Maybe you combine some of those moderate impact and high impact activities together across your lifetime to make significant changes in climate change, okay? One of the other things that we know has been happening is that our public understanding of science generally is correlated with a few things. For example, the more level of education you have, the more exposure you get to science and understanding. We don't see any gender differences, but we do see that if the more years of science and mathematics education, the more science and math class you've taken, as I was mentioning about employability, it also helps you to understand how science works. In addition, this NSF study from 2001, this sort of gives us an idea about how people understand it, how do they respond to a quiz and do they get the right answers. You can see, in fact, that most adults understand that continents move at the very bottom. They understand that light travels faster than sound because they have experience with it, like lightning. But they know that not all radioactivity is man-made, like an atomic bomb. But fewer of them know that the earliest humans did not live at the same time as dinosaurs. And in fact, many dinosaurs didn't even live together at the same time. For example, the Tyrannosaurus rex would have never seen a Stegosaurus, if you want an example of that. They lived almost 30 million years apart from each other. They understand, by the way, only about 50% of people understand the Earth goes around the sun once a year. Think about that for a second. Okay, these are basic things that most people should know. They should also know that electrons are smaller than atoms. They should know that lasers do not work by focusing sound waves. And they should understand what it means to the term molecule and how that's different from an atom, for example. But in fact, we can see that even in 2001, the level of scientific understanding is not very good. And in fact, that was actually in the peak year in many of those studies that I showed you earlier, where people generally valued science education more than they do now. Okay, so scientific inquiry moves by collecting information together. But that doesn't mean that all scientific inquiry is infallible. For example, we often seek knowledge, and by looking for knowledge in our culture, we often mean that we're looking for reductionistic explanations. We want to pick things apart, right? Reductionism is trying to understand complex things by examining their smallest parts. If I want to understand why people do something, I may not ask, well, what is it about their society or culture that leads them to be that way? Unless, those of you in the class who are an anthropologist or a sociologist, you probably are more likely to think about that. But psychologists and biologists and physiologists and doctors often look for examples that are related to biology. What genes do you have, right? Oh, why do you have ADHD? Oh, did your mom and dad have ADHD? Automatically, the underlying assumption, I guarantee you, for more than 50% of people is because you inherited genes from your mom and dad, those genes are what led you to have ADHD. But in fact, there are many other reasons, including the environment you're in, your amount of sleep habits, other things about how your parents raised you that are likely equally, if not more important, than your symptoms of ADHD, okay? So let's take an example of this. Why are humans monogamous, right? What makes humans monogamous? And in fact, we're going to take the example of titi monkeys. Titi monkeys are a South American New World monkey species. All New World monkeys that live in South America have prehensile tails, as you can see here. Titi monkeys look like those little fuzzy gremlins. They are adorable. They are monogamous. They're socially monogamous. The mom and dad form long-term pair bonds to raise offspring together. They have these long tails that they twine around each other. And every morning they get up and sing. They sing together, actually not as an affectionate, adorable, like, oh my God, they're in love. It actually, like in bird species, it is a defensive call. It says, this is my land, don't come near it, okay? They also, as they start to pair bond with each other, as they fall in love, if you want to oversimplify their mechanism of what's happening here, their brain actually reorganizes. Their somatosensory cortex changes so that their tails become more sensitive and they enjoy the experience of touch as their tails wrap around each other. For those of you that have been in love or are currently in love, think about the experience of cuddling up to your significant other. Does that mean that maybe in humans, when we start to pair bond, are we having the same kind of brain reorganization? An interesting question that we can't answer yet. So titi monkeys are monogamous, and in fact, they form those monogamous bonds to raise their offspring together. But unlike prairie voles, if you've heard about the love hormone oxytocin, we often talk about the role of oxytocin in forming pair bonds because of studies in rodents. Actually, in titi monkeys, it is not the hormone oxytocin. It's another hormone called prolactin. But in fact, I guarantee you that you hear very little about the role of prolactin and how prolactin, in fact, might help to reorganize pair bonding in humans, because we focused on this rat species because they're easy to study, and primates are more expensive, and there's not as many monogamous primate species. Okay, I want you to be careful about these oversimplistic explanations, right? We always go for, well, why do they fall in love? Well, is it because of the hormones? Is it because of genes? What's going on in their brain? Which are all the things I just talked about. In fact, those are reductionistic explanations. Those reductionistic explanations tend to focus on biological, neuroscientific, or genetic causes. But in fact, there are many other things that we could ask about monogamy. Is part of the reason that humans are monogamous because of certain brain regions or certain chemicals we release? Sure. Is the reason people have schizophrenia because of certain brain regions or the chemicals they release in their brain? Sure. But in fact, the other reason humans are monogamous is because of individual differences in their behavior, right? Not all humans want to be monogamous. If you're not familiar with consensual non-monogamy, there's a huge amount of research out there about people in open, polyamorous, or other kinds of relationships, swinging, and et cetera, et cetera. There are whole courses taught about it in various places. In fact, one of the world's experts on consensual non-monogamy is actually at Sac State, if you're ever interested in doing research in that area. So in fact, actually, there are some individual differences. There's also some small group differences, right? That, in fact, people may be monogamous because their family and their friends are all monogamous. The things they see around them, their friend group are all monogamous, right? So it's small group behavior. Often, this is where psychology tends to focus on the lower part of this upside-down triangle, the individual behavior, the brain region, the cells. Neuroscience and biology really at the very bottom of this. But in fact, actually, social psychology might start to look at small groups. And in fact, sociology and anthropology then really only focus on these upper levels, right? Ecosystems, society, culture, and small group behavior. For example, part of the reason you're likely monogamous is because you grew up in a puritanical, mostly Christian culture, right? But in fact, lots of cultures around the world, but not all of them, are monogamous in their boundaries, right? We provide legal benefits, we provide financial benefits if you stay in a monogamous relationship. In fact, we also punish you if you are not in a monogamous relationship. It is possible for you to lose custody of your children if you are in a polyamorous relationship, and for example, you have a former partner, or you have someone who decides to sue you because they believe that polyamorous relationship is harmful to your children, okay? So in fact, there are a number of things. So if we want to understand monogamy, we can't just ask any one of these. We have to ask all of these questions, and all of these help us to understand. So please, when you're thinking about why people have schizophrenia or why people have depression, please understand that there's a number of things here. Your society and your culture, the small groups around you and your friends, your family, the individual behavior you and self engage in, your brain regions and your cells and your neurotransmitters. Okay. The last thing, in preparation for class on Tuesday, I want you, maybe the next time you're on campus, it's better if you're on campus maybe right before you come to class. Take 5 to 10 minutes. I want you to sit down somewhere on campus, and I want you to just have a notebook, and I want you to just write. Tell me what you see. I want you to conduct semi-scientific observation. Make a list of all the things you see happening around you. Okay, bring that information in. It says on the slide 5 minutes. I would say somewhere between 5 to 10. 10 minutes is, if there's a lot of people around, 10 minutes is probably maybe too much to get all that information. If it's towards the afternoon, or if it's early in the morning, or if it's in the evening, you may not find as many students on campus. So in that case, if it's not as busy, you might need to choose a 10-minute observation window. Bring those observations into class on Tuesday, and we'll talk about them. Thank you very much. Email me with any questions.